Find a partial fractions decomposition for 2x squared minus 5 over x cubed plus 3x squared. So first thing we should probably do, factor this denominator. You can see both terms have an x squared, so we'll pull that out. So we get x squared and then x plus 3. Notice that we have a repeated linear factor, so that alters our setup a little bit. And it was 2x squared minus 1, right? No, minus 5. Minus 5. Okay, so how do things change? Well, we just get an a for our single linear factor, x plus 3. But then for each degree between 1 and, in this case, 2, we get a new term. So a b over x and a c over x squared. So that fixes things for us. Okay? And as usual, you're going to want to multiply both sides by this denominator here. Okay? That'll leave us with a x squared, bx x plus 3, and c x plus 3. Okay? Take some time, verify it for yourself before moving on. So now let's try and plug some values of x in here to figure out what's going on. X being equal to 0 would certainly make things a little easier. Okay, over here we'll get negative 5. And then it'll be a times a 0, b times a 0 times a 3, but we'll just write 0 here. And then c times 0 plus 3 is 3. So we get negative 5 is 3c, or c is negative 5/3. Great, we've got c. What else could we do? Well, I notice b and c both have an x plus 3. Is there a value of x that makes that 0? Yeah, negative 3. So let's try negative 3. Now, 2x squared, so that's going to be 2 times negative 3 squared, so that's 2 times 9, 18, minus 5 is 13. So b will have a 0 and c will have a 0 with them, so we can safely ignore what they are. So we'll get 13 is a times 9. So a is 13 ninths. Okay. Now, we found a way to isolate a by getting rid of the b's and c's, multiplying them by zeros. We found a way to isolate for c, because we could just plug in x equals 0 to get rid of the a's and the b's. But there isn't something we can do for b. But that's okay. We know what c is, we know what a is, so we can just pick any value we want. I usually pick something simple. 0 would be good, except we already used 0. So how about we use 1? So 2 times 1 squared minus 5 is negative 3. We'll have a, which is 13 ninths, times 1 squared. b times x is 1 times x plus 3 is 4. And then we'll have c, which we said was negative 5/3. And times x plus 3, but in this case x is 1, so times 4. So let's do a little bit of cleanup. Now, I'm noticing that I've got some fractions here. I'm going to make sure everything's over 9. So I'm going to rewrite negative 3 as negative 27 over 9. 13 over 9. 4 b's. And then 5 and 4 is 20. We're going to get a denominator of 9, so we'll say 60. So minus 60 over 9. Okay. So let's see, we can add 60 over 9 to both sides. That'll be 33 over 9. Minus 13 will leave us with 20 over 9. Okay, just going at your own pace. You know, you don't have to do it as quickly as I do. You also might do it faster than I do. But it's always a good idea anytime you're doing this to show your work. That way it's easier to check that you've done things right and to find errors if you make them later on. Dividing by 4, we see that b is 5 ninths. Okay, because 20 over 4 is 5. So now I've got all my fractions with their constants up on top worked out. So it's x cubed plus 3x squared was. And so A was 13/9. And we put A over x plus 3. And then it was over x squared. Okay, and the 5 we worked out was -5, or the C we worked out was -5/3, and B we just worked out was 5/9. Okay, there we go. I suppose if you wanted to, you could make a subtraction here. Okay, but that's about it. We've got our final answer indeed.